Well, hello again. This is Mr. Tom here with another video for you. It's 1 week later, airs 1 week longer. I'm actually filming this from home today. As you can see here, I've got my workspace set up here. This is a writing desk that I actually converted into a little workbench. I like to do some woodworking projects and things like that as sort of a hobby. It's also a good spot to do some experiments. So we've got two little experiments for you. First, we are going to be demonstrating how to make a lava lamp. That one's pretty cool. And then I'm going to show you the floating egg experiment. All right, so let's get started. So as you can see here, we've got a mason jar that I'm going to use as the container for my lava lamp. Now, first thing, I'm going to take some vegetable oil and fill it, say, around 2/3 of the way to the top. You can even use baby oil for this. I've found it doesn't really matter too much what kind of oil. Just keep in mind some are going to be a little clearer than others, maybe a little easier to see the effects you're going for. But that should do it right there. That's about 2/3. And I got some water. And I'm going to add just say 3/4 to about 1 inch of water to this particular jar. About like that. All right, now this is going to take some time. But eventually you will notice something. These two liquids will actually separate. If you remember from last week's video, if you watched that, I hinted a little bit about something called density. Density has to do with how much matter a substance has in it, or just kind of think of it as how much stuff it has. If it has more stuff in it, that means it's more dense. If it's more dense, that means it is going to sink below something that is less dense. Now, this is going to take just a little bit of time, so I'm going to pause this real quick. Now, you should be able to see fairly clearly that these two liquids are not really mixing. They're separated into layers. And remember, that has to do with density. So in this case, the water on the bottom is more dense than the vegetable oil on top. That's partly to do with their sort of molecular structure. So water, as you may know, is H2O. And oh, by the way, this is my cat Vincent here. He's been my assistant with my experiment. Yes, it's not time to eat. Thank you. All right. So as I was saying, water more dense than the vegetable oil on top, partly to do with their molecular structure. Also to do with the fact that there are lots and lots and lots of water molecules that can fit into tight spaces, so it's actually more dense compared to the vegetable oil here. All right, now next we're going to add a food coloring of your choice. Let me angle that down here. You can see my mess down there. I had to do some rearranging. I'm going to add, let's say 4 drops. 1, 2, 3, 4. I pick green. All right, now this is going to, Vincent, could you move, please? This is going to take just a little bit of time, but you want to see what happens to the food coloring. Does it sink? Does it mix with the water? Does it mix with the oil? We'll find out. All right, well, as you can see, the food coloring mixed down into the water layer down at the bottom there. All right, now here's the fun part. I'm going to take this effervescent tablet here. You might have heard of something called Alka-Seltzer before. So some people would take Alka-Seltzer, kind of help with an upset stomach. It's like an antacid. So I'm just going to take a half tablet here, plop it in. Now, I want you to make a prediction. What do you think will happen when I drop it in there? Let's find out. See that? So here we have our homemade lava lamp. Now, just a little bit what's going on here. So these tablets have carbon in them. Carbon is a type of element. And what's happening is called a chemical reaction. The carbon inside that tablet is mixing with the oxygen and water. Remember, water is H2O. So carbon mixing with oxygen, it's actually forming something called CO2, carbon dioxide gas. I'm sure you've heard of it before. You might also know it as the fizz or the bubbles that are found in your soda. So what's happening is when that tablet is dissolving, see here, I'll plot the other half in here. When that's dissolving away, the bubbles are rising. They rise, and once they get to the surface, actually that gas is being released outside the jar, and then they sink back to the bottom down to the water layer. Pretty cool. Now I want to show you something at the end actually, but first we're going to do our second density experiment. Let's get that started. For this experiment, you're going to want 2 glasses of water. It can be a plastic cup, that's fine. These are actually just a couple of salsa jars that I'm using here. They each have the same amount of water. And what you want to test is to see if an egg will float or sink. So this is just regular tap water, nothing added to it. Took out an egg, and then you want to carefully place it in the water. Now, see, as I'm doing that, that water level's rising up, so you want to make sure you leave enough space so it doesn't overflow at the top. But what do you think will happen? Do you think, here, I'll go ahead and hold it up, do you think it'll float or sink? It sank right to the bottom. Remember what we talked about density. If the substance is heavier, that means it's more dense. In this case, the egg is heavier. It's more dense than the surrounding water, so it sinks to the bottom. Excuse me. It's not time to eat yet. All right, now we're going to do the same thing in this jar, but instead this time we're actually going to add salt to it. We'll see if that has any effect on it. Got a measuring spoon here. I'm going to start out with a tablespoon. And you could put the egg in there first and then add this. I just find it's a little bit easier to see for demonstration purposes anyway. If you go ahead and put the salt in there first. Now, I added 2. Now this is number 3 here. If I remember right, you are going to need multiple teaspoons here. I'm going to start off with tablespoons. I'm going to start off with 4 tablespoons of salt here. Now I'm going to stir it up. Mix that pretty well. So now what happens, it looks pretty cloudy, but eventually this will actually go clear. And that's because the salts, the molecules in the salt actually break apart into really, really small microscopic particles. They're actually so small that they can fit in between the water molecules. So that's why it will eventually look nearly clear. Of course, right now there's quite a bit of salt in there. Might want to take several minutes to do this, so I'm just going to pause this real quick. So as you can see, the water's still a little cloudy in there. That's all right though. I'm going to take my second egg and I'm going to slowly place it in there now. Make a prediction. What do you think will happen? Do you think adding the salt to the water will have any effect? Will the egg float or sink? There you go. So what does that mean? That means the egg in this jar was more dense than surrounding water, but in this case it is actually less dense. So in other words, we were able to make the water more dense. How did we do that? Well, we added the salt to it. So even though eventually most of this salt will dissolve, might even look a little more clear, the salt molecules are still in there. So that means that water is actually heavier, and so the egg will still float. Pretty cool. Now, I promised you I was going to show you something pretty cool with the lava lamp experiment. Let me take you to that. So here we have a glowing lava lamp. What I've done was I placed a flashlight inside a mug, and I have the jar on top here very carefully balanced on that. So I want to make sure I don't tip it over. But watch this. Pretty cool. All right, well, I hope you enjoyed this video. This is so mesmerizing. I hope you had fun. I will see you next week for the next video.